Alright everyone, Mr. Claxon back again for part 2 of 5.1. Went a little longer on the last one than I intended to. My intention was only to introduce you to quadratic functions and then show how to determine whether the graph of a quadratic function, known as a parabola, opens up or opens down. In this one, I would just like to show you very briefly, because many students were able to understand this, I was just going to show you what we did in class to multiply the binomials here. And the reason why we're even doing this is because we want to convert it to a standard form. We want to convert it to the standard form of a quadratic. I mentioned it in the last one, and I'm going to mention it in this one as well. In this video, very important that you know it. The standard form of a quadratic, which is f of x set equal to ax squared plus bx, that's b times x. I could put parentheses around that. I'm going to choose not to right now, plus c. So that's our whole purpose in using the distributive property to find each product. Understand, we are multiplying binomials right here. We have a binomial multiplied by a binomial. The way that everyone remembers to multiply two binomials is FOIL, right? Keeping algebra fresh every day. We've got this FOIL method here. That's nothing more than a process to multiply two binomials. It's a mnemonic device to help you remember that. You could also use the distributive property if you wanted to be a pure mathematician here and use something that actually exists within the realm of mathematics, the distributive property. So the distributive property says that we are multiplying a quantity times a value times a quantity of values. So down here you can see how I just use the distributive property to first multiply that x by the entire quantity of x minus 1. You can see that over here. I then multiply the 1 by the entire quantity of x minus 1. So x times x minus 1 and 1 times x minus 1. That's how we're using the distributive property. Some people like to call it the cover-up method. I'll go ahead and grab the eraser here just to show you that real quick. I cover up the 1. And if you see, you can see then very clearly that all you have left is the x times the quantity x minus 1. I cover up the x. Notice how there is a positive in front of that. So it's positive 1 times x, and then positive 1 times negative 1. So positive 1 times the quantity x minus 1. That's how we use the distributive property. An example of that, another example of that is for number 3 down here. You can see that the x is multiplied times the quantity 4x minus 7, then the 5 is multiplied times the quantity 4x minus 7. The two quantities will stay the same. The only thing that changes is what you're multiplying. So if you look up here using the cover-up method, which many students remember that a lot better than the distributive property, just cover up the 5, x times 4x minus 7, cover up the x, 5 times the quantity 4x minus 7. And then the more, I guess you'd call it the more traditional method, if you wish. That's the method that most students remember, most students learn, that mnemonic device FOIL. If you would prefer to use that, you are allowed to use that for this section. Some people will not need to use any method. They will just be able to multiply and combine the like terms in their head by multiplying x times x, x times 9, which is 9x, 2 times x, which is 2x. So x squared plus 11x, and then plus 2 times 9, which is 18. So talking kind of fast there because I just really want to give you a picture of what we've done. Many students, like I said, got this. If you're looking to complete problems 14 to 26 even, I've done an example problem here, an odd one, and then 27 to 40 all. I show you to look at the leading coefficient. Again, we have standard form appearing again. So very important that you know that standard form of a quadratic function. For 27 to 40 all, we're trying to determine 27, 28, 29, 30, 31, 32. We're trying to determine whether or not it is a quadratic function. You do that by looking first for a variable raised to the second power. I have a variable raised to the second power here. Although I don't see any other variables, this is really all I need, and I need to see that if there are other variables, they can only be raised to a power of 1 or 0. And this, in fact, is raised to a power of 0. That's like saying 3x raised to the 0 power. Now, x to the 0 power is nothing more than 1, so usually we do not write it out as x to the 0 power. That's like saying, so anytime you see a constant, it's like multiplying by a variable to the 0 power. Yes, this is a quadratic function. It does satisfy. It has something raised to the second power. No, this is not a quadratic function. In fact, this would be a linear function because its highest degree is 1 here. 30, if you look at 30, it doesn't even matter what we have up here. It is the denominator. In the denominator, I have a variable. Therefore, that disqualifies it from being a quadratic function. It is a rational function, in fact, because I am dividing two polynomials there. We've got 31. I see 31 is not a quadratic function because of t raised to the third power. You can try some of these problems right here and check the answers from the homework. I'll give you all the answers right here if you so wish. And then we did lead into 5.2, but I'm not going to put that on this video. So go ahead and stop now. If it is playing, we'll stop the record player.